All right, it's time to be one of the winners. You've been following the show. You know every week we have Who Wants to Secure Clusters, the very well popular game that you have been watching every day. And today you are live and you are maybe one of the winners of the day. All right, let's introduce ourselves. My name is Henrik. I've been the host of Who Wants to Secure the Clusters since the beginning, but also a cloud native advocate working at Dynatrace, more than 4 years. And I'm also a CNCF ambassador and also an observability geek. So if you follow Is It Observable, you will have a lot of observable content for the people who love to observe.
And hello, also from my side. My name is Simon. I'm a senior product owner at Dynatrace for a threat intelligence team. And before that, I was in a cloud-native security research team. So played around there with the CNCF tooling and basically learned to love the community there. But Henrik, how do we play today?
Well, you know, you've been following us, you know how to play, but let's remind for those who never played it. So, there will be 5 themes around security, of course, because we're talking about security today. There are going to be 7 questions, and there will be 1 winner. So, if you want to play, scan the QR code, you will join into the Slido game. And again, the fastest will probably get some points. So, ready for the next questions. So, let's start.
Okay, and if you can't read the numbers, it's 1731182 on slido.com, or you can scan the QR code. But before we start, one small disclaimer. We do not want to criticize any tool at all. This is based on the experience we had when testing the tools. And if you say, there is this one tool that's so much better than what you showed, that's totally fine, because you did your research. And this is our goal today, to give you like a brief overview, and then you get back to your own research and check for your use case if it's the right tool. So let's kick it off with the first question, which is, it will come again, so you have a chance to join later also. The question is, cloud-native security can be compared to which of the following? And now we switch to Slido. And there you will see the QR code again on the left side. So please join the quiz if you haven't done yet. Also for the people who still come in, grab your device, scan the code.
You could be the winner today.
Already a lot of people in there. Also, you will have 20 seconds to answer the question, but be fast. If there is a tie, the person who was faster will win at the end.
Simon, why are you playing? You see me playing. I don't get it.
You're playing?
Yeah, me. There's me playing.
Me, yeah. Okay, then let's start. 20 seconds. The answers are either cars, hotels, food, or flights.
You have 20 seconds, so you may have been joining KubeCon through an airport, having a lot of problems. Maybe that's the right answer. Let's figure out.
5 seconds left.
Or maybe it's a hotel, or could be also a car. And the answer is...
many tipped on flights. What is the correct one?
Hotels.
But why is that?
Well, if you remember well, you arrived, you took your hotel, you have a nice room, secured. That's a bit like a pod. Because in your room, you have in your hotel room, you have the bathroom, which is another container. You have different services around your room. But then, your pod is able to, with your card, you have access to the entire floor, which is an M space. And if you remember well, you've been using your key card in a hotel that gives you access to only your floor and to certain services of the hotel, which is maybe the gym, the laundry, or whatever you have in your hotel. So this is a bit like a service account, giving you access to certain access in the cluster. But tell us more.
There's more to that. Of course, you also want to ensure that nobody can get into your room, for example, from the outside, like a window, and also like for the door that only you are allowed to enter it. So you set certain privileges, and also like in the cluster, you normally do penetration testing, so nobody can get in who shouldn't get in. And also in addition to that, you probably want to ensure that the material that was used to build up the building itself, the hotel, is safe. And in a cluster, you do this by scanning, for example, for common vulnerabilities and exposures, by, for example, using the software bill of materials to check what's in your cluster. Is there something vulnerable in there? And we're using this grouping for this whole talk for the categories. It's from the Cloud Native Security White Paper. There are other groupings out there. We use this one because I think it's quite easy and quite nice to illustrate. Starting from the left to the right, we have develop when you build and write your code. Then you have the distribution phase when you're actually building the container image, and there you scan for vulnerabilities.
And then you deploy. So in deploying, maybe you will have some specific access you want to give to the containers, like avoid having escalation privileges. And then, of course, containers can, the pods can by default see all the pods of the namespace or the cluster. So maybe do creating a network policy or securing the communication between the different services. And last is, we are in the runtime, your containers or pods are running, then maybe there are suspicious things going on your cluster. Or maybe there's a runtime vulnerability that has just raised up, so we want to detect that. All right, so let's start and roll the dice to see which category we're going to have. All right, which category is going to be?
Security policies.
So security policies, we have a couple of requirements for that. Remember, we want to have best practices in our cluster. We don't want to have our users setting root privileges to containers, that doesn't make sense. But making that, crossing the fingers that all the user will respect our best practices doesn't work. That's why we need a policy management solution that would basically rely on the admission controller. So if you never heard about the admission controller, when you interact with the API server, it will go through the mutating admission controller that will reach out to any other solution out there to basically transform your workload by adding mandatory labels or privileges. And then we will go to the schema validation, and last we go to validation controller, where we could validate or block workload that are not respecting our workload. So for that, we will have CRDs to helping us to create privileges. But those tools, usually you are not all expert in security, so having predefined rules would be almost a requirement for us. And of course, having just detecting events is great, but having reporting is going to be very important, because at the end we need to understand what's going on in our cluster. So the tools that we're going to cover here is going to be on the Kyverno, very well known, you heard about it during this KubeCon, and we will have OPA Gatekeeper.
But which one is the most powerful one? So bring up your devices again, be ready. 20 seconds, as usual. Is it Kyverno or the OPA Gatekeeper? 15 seconds left.
Maybe you're using one of them, maybe that's the right choice. So bet on the solution that you're using, just think twice. And remember, there's the latest update on the admission controller. Maybe that brings some values.
And the answer is
Kyverno. Wow, awesome. A lot of people won here. But why Kyverno? Well, Kyverno provides the ability to build policies in our cluster without having a specific language. It doesn't rely on Rego, even if now with the new latest admission controller, you have the cell language that you can define precise rules as well. But out of just validating or mutating, it can do more. It has the admission controller where you can basically block or mutate workload or objects that are being deployed. It has the background controller where you can generate events. You can do things in the background, which is fantastic. That's a cool feature. You can clean up. You can basically clean up means deleting resources that may run in your cluster, like jobs or services that are unattached to any pods. And last, it has the report controller, so you can expose reports and produce a lot of the data out of it, which is fantastic. And one thing which is amazing with Kyverno, it comes with a Helm chart with predefined policy. So you have no clue of which policy you're going to do. It's very simple. You deploy the Helm chart, and you all have predefined rules. Then we have OPA Gatekeeper. OPA Gatekeeper is basically been out there since a while. It's able to validate, to mutate workload, and report. So less features than Kyverno. OPA Gatekeeper relies on a Rego script. So if you love Rego, perfect. If you don't like Rego, then it could be a problem. But also it supports Cell with the latest updates of OPA Gatekeeper. But the thing how it works is you have to create a constraint template with the Rego scripts and the parameters. So that will be like almost like a CRD, and then you will have to create the constraints, which is the actual policy. So at the end, you're going to create a lot of CRDs if you have a lot of different policies out there. OPA provides constraints templates, which is the templates, but it doesn't have the ability to create your own rules. So you will have to create deploy the constraints templates and then customize them based on your needs. And then last, so here is basically the conclusion. We selected, so I did a benchmark on terms of latency and performance. So OPA is a bit less consumed, a bit less CPU and memory, but in terms of latency, Caverno was faster, and also from a feature coverage, Caverno covered what we needed. So that's why we decided to select Caverno for that need. All right, let's move to the next theme. Let's roll the dice.
Oh, it's static analysis, or in more detail, compliance and configuration. We heard in the previous talk that this is actually important to do. But what are the requirements there? Like back to the hotel, when you want to build something, at least the country where I'm from Austria, and you need to have a building permit that it is allowed to build. And I think this is good because then you can really know, should we actually build there? But in addition to that, normally a hotel also has checklists that they need to fulfill from time to time. And they also have inspections, like checking stuff, whether it's still fine. And in Kubernetes, you're basically doing the same. You have like certain benchmarks, like the CIS, NSA, NIST. There are a lot of them out there. And you also want to check for certain misconfigurations, like RBAC, certain Linux capabilities set. And then in the end, you want actually actionable results. So when there was a finding, you want to fix it. And in the best case, you have a hint on how to do that. And we have multiple solutions there. We heard one before. Going from the left to the right, we have KubeBench, and it's also somewhat also integrated in Trivy. Then we have kubelinter, we have kubesec, and then we have kubescape.
So the question is, which of the following tools is the most powerful? So let's go to, again, go back to Slido. We will have 20 seconds. And for the compliance and configuration, is it A, KubeBench from Trivy? Is it B, kubelinter? C, kubesec? Or D, kubescape?
And as a hint, more than one.
All right, 2 seconds. And, interesting. And
okay.
Why do we have those three solutions selected?
Yeah, let's go over them and check out the details here. Like KubeBench from Aqua Security, it is basically focused around the Internet, Center for Internet Security Kubernetes benchmark. So this is a CLI tool that you can either run locally or, of course, also in your CI pipeline. But the nice thing is also Trivy has this integrated. You can run the benchmark also there. Then we have kubelinter, a little bit a different approach. It actually checks for production readiness of your Kubernetes manifest files and also your Helm charts, so that actually your application is secure, is reliable, things like that. And you usually run it as a pre-commit hook, for example, or in your CI pipeline, or even as a quality gate before your pull request is merged and then deployed. And it comes also with predefined checks, which is nice, so you don't have to be the security expert because the knowledge is already built in. Then we have kubesec from Control Plane, similar approach. They check for security controls, whether they are set, for example, whether the run as non-root is missing, things like that. And they also include 20+ checks focused on security. And then we have kubescape from Armo. They provide a lot of things out of the box, especially multiple compliance frameworks. And then they have also things like runtime detection, vulnerability scanning, you name it, things like that. And it's quite flexible in deployment. You can rather run it in your CLI. You can run it in Kubernetes. And they also have a SaaS offering if this is something for you. And there we also made the comparison based on integrations, Kubernetes native support, reporting capabilities, like kubescape is very strong there. Why did we choose also other tools? Because when you want to have something really fast, like in your CI pipeline, or either run it locally, we also included kube bench and kube linter. kubesec has a little bit less already pre-built rules defined, and therefore we would rather prefer kube linter in this regard. Okay, let's go to the next category. What will it be?
Right. I'm very surprised to see what it's going to be. Observability. Ah, secret management. So, secret management, what are the requirements? Well, you know, you're relying on secrets, maybe Kubernetes secret, which is super well encoded with base64, you know that. So, which means, because it's base64, you don't want to put in your GitHub repository or in your source control. You want to make safe. So that's why we try to build it, deploy it through different process. So having a secret management where you can at least encrypt that source somewhere in your source control, that would be a must. That's one thing. The second thing is, be able to basically provide a real encryption. Because if a hacker takes control of a cluster, it will take him maybe less than 3 seconds to decode your base64 decoding, so it doesn't make sense. So having the options to have this secret really encrypted is going to be very, very important. And a last thing that as a requirement we need is basically have a way of storing centrally our secrets, not necessarily in Kubernetes, because maybe one secret could be the same on various clusters, would be interesting, so have sort of an external vault would be very important. So here is the solution that we're going to test here. The external secret operator, you may have heard about this solution, and the other one is SUPS. SUPS is an amazing project, but it also has a SUPS operator, so we will also touch base on this one. So the question is,
which one is the most powerful one? Let's go to Slido again. 4 options here. Get ready. We have external secrets, of course, or both, SUPS or none. Let's see what it is. 10 seconds left.
Keep in mind the requirements. I listed the requirements. And if you don't know, maybe it's the time to call your friends. You have one call allowed in that talk.
Okay, many voted for both, and the other external secrets. The solution is?
None. Well done. Well, let me explain why we select none. So external secret operator is fantastic. It basically has the providers that could be vaults. So basically it's resolve one part of the equation where we will manage externally our secrets in different roles. So it could be Azure, AWS, you have name it. There's plenty of solutions. And then you create what you call an external secret store. So basically you define where is that secret store, and then you will define the external secrets that will basically make the reference to that vault. And so that means we can store in Git these details because nobody can understand what's the actual secret. So that's perfect. So they're resolving 2 elements of the equations, which is fantastic. You can also generate a password. You can sync to the value of your secrets to version vol. So that's what we want. That's perfect. But at the end, what it does, it takes our vault secrets, bring it back to the cluster, and create a basic base64 secret, which is no. Now, we move on to the SUPS operator. The SUPS operator rely on SUPS. I don't know if you heard about it. So the usage is a bit more complicated. You need a CLI, SUPS, where you can rely on different way of encrypting using age or PGP. So you need to have a public key, very secure, that is related to your laptop. So it means you can encrypt the secret, store it in Git, and nobody's going to decrypt it, or if you have a very munching quantum computer, maybe it will happen, but nobody has it. And then once you have it, you will basically create a SUPS secret that will basically take those secret, the encrypted value of your secret, and then when you deploy it, the operator will do, it will decrypt this super great secret into a base64 secret again. And the other downside I didn't mention for the external secret, it's the same thing. The public key that you're using for your decryption is a secret. Again, a base64 secret. And then to go back to the external secret operator, I didn't mention that, but also the reference to the vault and the password to the vault is, again, a base64 secret. So if I'm a hacker, I take control, I can access to the vault, get the details, so I'm going to be very well compromised. So at the end, in terms of feature coverage that we expect pretty low, we want to have something more secure. Documentation, I think external secrets is pretty great, to be honest. In terms of CPU and memory usage and measure, it's about the same, nothing special. They provide very low footprint. On the observatory side, external secrets show you a lot of details, but SOPs is basically silent. Next category.
Okay, what will it be? Hopefully, vulnerability scanning.
Observability,
Come on.
observability.
Yeah, vulnerability scanning. So we had misconfigurations, which was like one half, and now we have the other half, the vulnerability scanning. But why do we actually want to do that? Okay, back to the hotel again. It's safe from the outside, but we also want to be safe in the inside. Like the doors work as they should, also the locks there, or the elevators, they should be safe. Same for your cluster. Like the container image that you use and the operating system in there, it should be safe. And also the tech stack in there. Let's say you have a Python application, the libraries that you use, and all things around that should be safe. And how this normally works is you have certain vulnerability databases. For example, NVD, National Vulnerability Database, is a big one, GitHub Security Advisory, and you use them and basically use everything you find in your container and check it against what is found in your image. And then you need to prioritize these findings, because like getting alerts is easy in security, but then you have the problem of alert fatigue. Where should you start when you have 1,000 alerts? And there it helps to have like exploitability, things like that in your findings. The tools there are the OSV scanner, Claire, Trivy CLI, also the operator, and then Sift and Gripe, because they're mostly used in combination together.
So prepare, open Slido, and the question would be ready, come on. The question is, which of those 4 solutions is the most efficient, depending on the requirement we just listed? Is it A, OSV scanner, B, Claire, C, Trivy operator, and D, Sift and Gripe? We should have added a small, music like
thinking music.
In 1 second.
Okay, we have the results. They're coming in. Oh, it's Trivy. Is it the correct one? It actually is. Good job. Going through the scanners here, OSV scanner. This is a project by Google. Actually, it isn't CNCF, but still, like OSV is open SSF, so I think we can include it. And it's a really nice tool to use because they have the central database. You install the CLI locally, and it checks against this database. And the positive thing is they crawl from multiple security advisories and normalize this format. So you have like one format for all of your findings. Then we have Claire. And I would say it's more for the enterprise side because it's, for example, used in EWS ECR, in the Elastic Container Registry, and it's made of 3 different parts. You have the indexing, you have the matching, and then the notification logic. And the positive thing is it's quite sophisticated on how you want to deploy it, either distributed with multiple databases even, so that's really nice if you need that. Then Trivy, it seems a very popular one. You can run it either locally, in CI, in CD, and also natively in your cluster. So you have your custom resource definitions, get your vulnerability reports, your config audit reports, things like that out of the box. And they also crawl a lot of data sources, which is quite nice, especially OSV operating system ones and also language-specific ones. And in addition to that, you can even define your custom checks in the OPA Rego language. And then we have Sift and Gripe, and you could also include KubeScape there because they use Gripe under the hood. And they're mainly used together because this pinkish guy there, it generates SBOMs, so software bill of materials, which checks what is in your container image. And then you have Gripe, which calls all of the different advisories, please give me the security information, and checks this against the SBOMs, and then give you the results that you need. But why did we choose Trivy then? Because basically, there are so many ways on how you can run it. You can start locally and then go fully fledged, like in your Kubernetes cluster. Of course, OSV scanner is also nice, quite easy to use, also clear for the enterprise context. But overall, I think Trivy is a good way to start by scanning for vulnerabilities there. Okay, going to the next question. What is your category there?
Please, 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 please.
Oh, runtime threat detection.
So runtime detection, what are the requirements? Okay, so you know that our hacker will take control of our containers. They will probably try to compromise your processes, spawn up new processes in your containers, have access to your secrets, so read files at the end. Maybe also scan the network. So you need a solution that is able to detect those type of events in a cluster. And for that, the only solution out there that is able to do silently is you relying on eBPF. So one of the requirements is to have at least eBPF evolved in the architecture. And also other than we will define those policies. But you know it's very complicated to define policies on the process level. So having predefined rules will be very, very important. And last, detecting things is great, but blocking is even better. So here are the 4 solutions. We have Falco from Sysdig, Tetragon from Isoviolent or Cisco, CubeArmor from, I don't remember, and then we have CubeScape from Armo. So the question is,
you know the game, which is the most powerful one, according to our research. Going to Slido again. And here is the question. A, Falco, B, CubeArmor, C, Tetragon, or D, CubeScape.
So if you've been using one of them, maybe it's the great choice. So think twice. Is it blocking? Does it have predefined rules? Does it rely on eBPF? Well, we'll see.
What will it be? Oh, yeah,
Oh.
It's balanced. Interesting one. Let's check. It's Tetragon and CubeScape.
Why? Let's start with Falco. Falco is a rule-based engine. And Falco comes, when you deploy it, with their predefined plugin, which is the kernel plugin, which is an eBPF agent. So it's going to be able to detect whatever we want it in terms of processes, everything going to happen on the kernel. Falco is extendable with the SDKs. It's exposed a lot of things. But the way you defined, it has predefined rules, which is amazing. So it starts Falco with a huge file with a lot of rules. So customizing it could be quite a bit of a challenge. And last, Falco is detecting, not blocking. Tetragon is basically producing events by default only on the policy that you deployed, except for process execution and process ending. It's basically pretty much hooked into the eBPF world where you define hooks on your policies. Is it kprob for kernel functions? Is it tracepoint for kernel events? Is it uprob for user functions or LSM? So Tetragon is impressive on what you can achieve in terms of configuration, but it comes with a price. It's super complicated. You need to have some expertise in the kernel level. And also the tracing policy, which is a CRD you configure, you can do amazing things to block. You can just customize the way you want to block it. So it's pretty impressive. Then we have CubeArmor. CubeArmor is an operator. It's an amazing solution. It's basically won't deploy anything, so you will have to deploy the policies to be to have events generated. What is interesting is you have annotations. So based on the annotations, it could react differently based on the annotation that you have defined. So that is a very interesting feature. It has a repository with examples, but it doesn't have predefined rules. So you'll have to define your own rules, and you'll see that it has its own sets of defining it. And that's going to be tricky. I think we're going to overtime. And then CubeArmor is able to block, but yeah. CubeScape is very interesting. CubeScape provides a node agent in the solution, because you see we named CubeScape a lot of time in that talk. And the way doing it is they have a learning curve. So they learn your app, what they're doing in terms of processes, files, and so on, and then they detect the differences. If something is a new process has been spawned up in your cluster, that seems weird, so they will raise an alert. So the way you're detecting is very interesting. And what is great with CubeScape is it comes with predefined rules, so no way of configuring, it's very simple, but it doesn't react. So here is the results, why we choose both CubeScape and Tetragon. So Tetragon is a beast in terms of utilizations. CubeScape cover everything, is very simple. And then we cover also the CPU utilizations, the eBPF consumptions on the cluster as well, because you have to consider that aspects when you rely on eBPF. Last question.
Okay, before we come to the results, if you listened in the beginning, final question, as a recap. What is the lifecycle in the cloud-native context again? Switching to the Slido, last question. So this is your chance to collect the last point. Is it A, plan, build, test, release? B, develop, distribute, deploy, runtime? C, cloud cluster container code? Or D, design, provision, harden, operate?
All right.
Okay.
If you follow the talk, you know the answer. 4 seconds.
What will it be? Okay, and it's B. It's develop, distribute, deploy, and runtime.
So here's the winner. Okay, so I don't know if you hear her, so come and join us after the talk, because we probably have some questions, I don't know. We'll give you the prize. So the prize is here to yours, so come and join us. So if you want to learn more about us, we have a QR code here. You have a lot of, if you want the details on the benchmark, because we did a lot of details here. There's a GitHub repo with all the tests we've done, all the results that we've done. So scan the QR code, very important. Otherwise, you can reach out to me on GitHub, on LinkedIn, and follow Is It Deliverable if you want to have details about those solutions.
Okay, so thanks for joining to a quiz show, and then have a good rest of your day. Bye-bye.